Welcome, everyone, and thanks for joining us for day 2 of Ecopia's virtual 3-day summit. Today, we're talking about broadband and public safety. Thanks again for joining us. As I was thinking about our session today, a phrase that came to mind for me was situational awareness. And for me, that can mean many things. For broadband offices in states, it's knowing which structures do not currently have access to broadband or have limited access in terms of broadband upload or download speeds. For public safety professionals and emergency responders, that means knowing the situation that they are entering into when they're responding to an emergency or an incident. It came to mind that for them, having as much data or information as possible about what location they are going into and the geography and structures that are there on the site they are entering is crucial to how they'll respond to that situation. Hello, everyone, and thanks for joining. My name is Dan Ross. I'm a strategic advisor for the public sector here at Ecopia. Prior to my time here with Ecopia, I served 28 years in the public sector in technical and leadership roles related to information management and GIS. I'll be the facilitator today for this great panel that's going to join us. We're talking data again today, and specifically how high-resolution geospatial data can assist you or your organization in planning, analysis, management, and decision-making as it relates to broadband and public safety. With that, and before we get into talking about the data, let me introduce our presenters today. Sean Lowry, over there on the right hand of your screen, is the Senior Director for Products and Business Development at Ecopia. Sean's mission at Ecopia is to develop viable markets and applications where Ecopia's advanced AI-based map data and geospatial solutions can transform decision-making in the sector. Prior to joining Ecopia, Sean amassed over 15 years of sales and product experience working in the geospatial industry for satellite imagery provider Maxar Technologies. When not neck deep in geospatial technology, Sean is busy coaching his kids or acting as if he can still play sports like he used to. That would be me too, Sean. Hillary Palmer. Hillary has 13 years of experience in geographic information systems, including 3 years as the enhanced 911 addressing official for the Manitousca. I'm going to get this one. It's a tough one, Hillary. Sustina Borough, where she managed key GIS data sets used in 911 dispatch and emergency response. Hillary has worked as a GIS analyst for the U.S. Army Corps of Engineers and the Alaska Department of Transportation, where she became aware of the many uses for location intelligence at state and federal government agencies. Palmer chairs the Urban and Regional Information System Association, URISA, Next Generation 911 Task Force, and is the Secretary-Treasurer for the Alaska chapter of the APCO-NENA organization, or the chapter, excuse me. Last but not least, Timothy Scott serves as a technology manager for the New Hampshire Emergency Services and Communications Division of the New Hampshire Department of Safety. He has been with the department for over 20 years and manages a diverse range of responsibilities, including Next Generation 911 networking, GIS data management, and 911 automatic location information database administration. In addition to those responsibilities, Tim's staff run and manage 911 support systems such as call recording, medical dispatching protocol software, CAD functionality, and statewide emergency notification system. In addition, Tim composes grant applications and formal requests for proposals, as well as manages programs and relationships with over a dozen 911 related vendors. My thanks to each of you for joining today. I'm really looking forward to what you have to share. Let's get started with you, Sean. Ecopia has come out with some high-resolution geospatial data that can clearly enable and benefit organizations and individuals who are involved in building out broadband and those in public safety and emergency management sector. Can you share a bit about the specific data and how those data are being leveraged?
Yeah, absolutely. Thanks, Dan. And seen a lot of familiar names out there. Thanks everyone for joining. I'm excited to be able to do this. So I wanted to give a little bit of background on Ecopia, and then talk about some of the data sets that we kind of built before this broadband stuff took off, and kind of how it came full circle, and then we'll pass it on to the others that are way smarter than I am at this kind of stuff, and we can talk about like some of the great projects we've done. So for those of you who don't know Ecopia, we created an AI-based engine that can take massive amounts of pixels and turn them into vector data at scale. And so our vision is to create a digital twin of the Earth, and we're slowly but surely kind of knocking that down by doing large-scale mapping, which I'll kind of get into. How we do this, we form relationships we have a lot of relationships with the imagery providers, whether it's satellite, aerial. We're dabbling in collecting our own imagery, whether it's, from the street, and throwing that into our workflow and pipeline, and making that as robust as possible so we can make as much high precision maps as possible. And I'll show you some of that. How it works, we created this AI-based engine that results in vectors that look like a GIS professional was sitting in the office hand tracing every nook and cranny. It was really hard to get there, and what we did is we used a lot of humans in the loop early to train our algorithms and to scale QC. And so while a lot of other, AI-based geospatial companies were putting out output that was automatically automated, but not necessarily usable, we were kind of focused on the QC end of it, of making sure that it looked exactly like each feature looks like in the underlying imagery. Over time, that quote unquote perfect data that we manufactured ended up going back in the algorithm as ground truth, and over time the engine just got better and better and better, where less human intervention was needed. So a lot of these images, we can kind of turn them into these types of maps where it looks like almost paint by number, where we're taking each feature that we can delineate in imagery. When we go super high resolution, we can get stuff like lane lines and bike lanes and all the crosswalks and everything like that, or individual kind of paint markings, or really impervious surface. But from the general standpoint, we can do all these features that you see here with 30 centimeter or 1 foot resolution imagery. Okay, so now I'm going to kind of focus back on what ended up serving this, broadband or statewide initiatives, and how we built this data set. So in 2018, I was on the other end of this. I was with Maxar, and we came together and said, let's go make building footprints for the entire country. And it was awesome. And it took 6 months, and it turned out nobody really cared, because they're just naked building footprints that don't mean much. So we then kind of looked a lot into, how do we attribute these? How do we make them more useful? And it got into this whole world of geocoding, which I'm sure we've all dabbled in, on how do you marry up address points with the correct buildings? And, what do you do? There's parcel-based geocodes, there's street level, and we wanted to kind of get this like building-based. Turns out it's super hard. As you guys know, there's lots of buildings that can fit in one parcel. There's buildings that can scan multiple parcels. There's lots of parcels with no buildings. There's sheds. There's all sorts of things. There's water tanks and oil tanks in a lot of complicated things. But we stayed at it. We created a machine learning based approach to grabbing as much address data as we could possibly find, and making it try to logically fit into the right building at the right spot, and then kind of give it a ranking system of like, how confident are we that we nailed this? And then we said, we're doing it across the entire country. So we built this. We ended up kind of building this for the insurance industry, but it ended up with a countrywide site structure address point, building footprint database that ended up coming in handy in both broadband and we're kind of exploring, can this be for next gen 911 as well? So that's why I invited as many of you as I could in the public safety, and Tim came in and can kind of coach us up on that. So we ended up with this countrywide geocoded building footprint database. We have this relationship with a satellite imagery provider where we get new imagery every year. Not every pixel covers every part of the country, but in general, we're getting new pixels over half the country, mostly centered on where things are changing. And so we've got this great engine that's taken all this data, mapping buildings, looking for the change. This is supposed to be a building slide, but it doesn't look like it's doing it. Where we can easily identify change, new, removed buildings on an annual basis, rerun it with our kind of address matching engine, and keep up to date with statewide, countrywide geocoded building footprints. Since we are on public safety, I did kind of cover like some of the other layers we're doing just from a land cover feature. I put this together. This is, we've had a couple mapping initiatives where we've helped public safety agencies, map driveways or other features that could be applicable during an emergency situation. In this particular one, we have parking lots, sports fields and sports courts, hydrology, pavement, swimming pools, things like that, where, hey, an emergency happens, could be back in the shed. It could be helpful to know there's swimming pools, but mostly it's been driveways have ended up being very helpful. Again, I think Tim can hit on that as he built out a statewide driveway database. Last but not least, 3D. So yeah, we cut our teeth in building footprints. We then went to land cover, and since have really gotten good at kind of like our height attributed building footprints. We built 55 million of these guys around the US metros over the last, 12 months. And we're using this to kind of build APIs or partner with people so that we can bring 3D buildings into the PSAPs. So when someone calls and they can't communicate what floor they're on, but there's wireless signals giving off an XYZ, we can start bringing in these 3D maps into the call center so they can identify where people are. But I think that concludes what I have. Back to you, Dan.
Thanks for that, Sean. As I was listening to you and thinking about the data, it brought me back to my days when I had the opportunity to work in the Emergency Operations Center in Minnesota, and how valuable it would have been to have building structures and that sort of thing. I think about the floods that are going on in Minnesota right now, and I think about where those structures could be essential in making sure that we understand what's going to be impacted and how bad that impact is going to be. Hillary, I know you're going to talk some more about that. Earlier today, I introduced Hillary. And of course, Hillary has experience leveraging geospatial for 911 and for broadband. Hillary, thanks for joining and sharing your story today. I know you're going to go into some things for us. Can you tell us a little bit more about your use of the data and some of these case studies or these efforts that you're working on now?
Yeah, absolutely. Thanks, Dan. First, I guess I'll talk about broadband, and then I'll jump over to public safety. They're different, but also kind of related. So thank you, everybody, for letting me speak to you today. I'm going to be talking to you about some broadband and then public safety applications for AI-derived data, specifically land cover data sets. Tiny bit of background up first. The NTIA was tasked with fairly distributing $65 billion in grants to ensure all Americans have access to the internet at broadband speeds. Of that 65 billion, 42 was diverted into a program called BEAD, and BEAD stands for Broadband Equity Access and Deployment. The funding in the BEAD program is being prioritized for any locations that are considered unserved, underserved, or are community anchor institutions such as schools and hospitals. A data fabric of broadband serviceable locations will be used to determine the allocation of the BEAD program grant funding that is available to each states. So of the $42 billion in the BEAD program, each state gets $100 million automatically, but that leaves the remaining $38 billion, still a very large number, is up for grabs. So basically, the FCC hired a contractor and told them to build nationwide map, nationwide data fabric of all the broadband serviceable locations. And they had, tens of millions of dollars and a year to do it. States tried desperately to stand up their own broadband offices and get up to speed about what this program is, what are its requirements, what do we need to do. And many are still getting up to speed and learning that they really needed to create their own version of this broadband serviceable location fabric, or BSL fabric. Challenges for Alaska were numerous. So the initial version of the FCC's BSL fabric completely missed 69 of our communities, most of which are remote Alaska Native villages. Remember that E stands for equity in the BEAD acronym, so that's a major problem. Further complicating things for Alaska was the fact that we have this massive thing called our unorganized borough, and it makes up over 70% of our landmass, and it ranks 4th highest in population. And here there is no local government to assign addresses or collect property taxes. It's just kind of a wild west up there, and it's data poor as a result. And so that's where a lot of the missed communities exist. So at an immediate disadvantage, Alaska was wondering, how are we even going to be able to improve the FCC's data fabric to ensure equitable representation when we don't have statewide addresses, when we don't have statewide parcels, and we definitely didn't have statewide building footprints. And we saw this massive opportunity of $38 billion, and we were going to be left behind. So what happened is we realized that even though we don't have statewide addresses, there's a way to sort of come at that problem from another angle, and that's through building footprints. Building footprints kind of represent your truth layer for where you should have address information, right? And if you look at it in context with parcels, even better yet. So for any other places that perhaps also don't have statewide addresses or statewide parcels, building footprints was a great way to help us bridge that gap in our geospatial data infrastructure as a state. Thankfully, the Rasmussen Foundation came to the rescue. It's a philanthropic organization up here in Alaska. They worked in collaboration with our Alaska Office of Broadband to fund a project. And Ecopia was contracted to leverage our statewide satellite imagery mosaic and perform building footprint feature extraction for the entire state. And then Dewberry's part of this project was to take the building footprints and derive, so building footprints were one data source. And then we also grabbed all of the authoritative best available parcels and addresses, mashed those all together into some analysis and scripting. And we generated several data challenges to help improve the FCC's BSL fabric. So here are some examples to show how building footprint feature extraction helps solve equity issues that existed in the federal data set. We see Cold Bay on the left and Adak on the right. These are both very remote, very small communities out on the Aleutian Island chain that otherwise would have been left behind. And look at all those gorgeous building footprints that Ecopia was able to extract. It really helped us. I mean, we had no addresses for these areas. So look at what we were able to do just by having building footprints in hand. And this is a map of Sitka, Alaska, which is a coastal town in the southeast part of the state next to Canada. So obviously building footprints were critical. They really bridged the gap between those communities that were well organized, well funded, and had great GIS data that's published openly, and those that didn't have any local government or weren't that well organized or well funded or well staffed or well trained, right? There's a huge gap there. So building footprints helped us bridge that gap. And this crazy thing we're seeing on the screen is just one small piece of the FME scripting that we used in order to do data conflation. This is a look at a piece of creating statewide addresses for Alaska, grabbing input data sets from address points, from spreadsheets, from parcel data, right? Because some physical addresses are stored in parcel data sets, mashing those together, putting them into a standardized schema that is parsed out in the fields. And we realized after we created this data set that for the purpose of broadband, we had created something that public safety was dreaming about having access to. So we said, you know, we're gonna do the right thing here, and we're gonna donate our time and resources to take that data set and then mash it into the NENA Next Generation 911 GIS Data Model version 2. It's a mouthful. But we did that, and then we donated it to the state of Alaska free of any licensing restrictions. So we're happy to have had the opportunity to sort of bridge the broadband and public safety worlds. We hope that folks at the state and elsewhere see the need and value in statewide addressing, and that they can cobble together, you know, collaborative funding for periodic updates. So you've heard the Alaska story, and from it we learned that there were some definite issues in the FCC's BSL fabric for our tribal and our rural areas. They ended up being underrepresented in the federal fabric because they're just generally data poor. So we tried to think about other states that might be in a similar situation, and we thought about Arizona because they have so much of their state is tribal. And it's you know, it's the Great West. It's wide open, spread out. So we reached out to Arizona, and we're very honored to have been able to assist them with their BSL Fabric Challenge process. Through helping Arizona, we also realized that areas experiencing rapid growth were also likely to be underrepresented in the FCC's fabric. So if either of those are meaningful to you in your state, you know, please think about developing your own version of the BSL fabric. Don't just take what the FCC has. We need to be able to have your version and their version and compare them. Let's make sure that we're, you know, getting appropriate funding. And I guess the biggest takeaway for me in this whole process was that states that weren't already well organized really struggled to get up to speed and, you know, find a point of contact at the FCC to ask questions of and learn about the process. And the deadline for submitting those location-based challenges had already passed before they even received their broadband planning grants. So it really put a lot of, especially Western states, at a disadvantage. And it's a big disadvantage. This is kind of my rough return on investment sheet. On the left-hand side, there's a column for number of BSLs added, right? It's just a guess. You can submit challenges, but it's up to the FCC what they choose to accept. So let's say that you find only 5,000 new BSLs for your state. You could be receiving anywhere from $1,000 to $50,000 per BSL, but it's probably going to be in the $5,000 to $10,000 range. Again, we don't really know what other states are going to find. So it's a rough estimate, but let's say that we get $10,000 for each of those BSLs. You move straight down to the likely ROI column. And that means that even if you only found 5,000 BSLs to add, you may get up to like a $50 million return on investment. I don't know about you, but never in the history of anything have I ever seen an ROI that high. So it's definitely worth the effort and the time to make sure that you have your authoritative data well represented. Okay, changing subjects completely, but sort of also related. I'd like to talk to you a little bit about what I see as the role for AI-derived geospatial data in public safety GIS specifically. it's kind of a catch-22, right? I know that from my experience in public safety GIS, we were very much authoritative. We could end up in a courtroom. Nobody wants to be there. So that was the name of the game. But then you're also in this catch-22 where most GIS departments and PSAPs and public safety are chronically underfunded, understaffed. It's a major challenge. And I know that in years past, I have been watching funding for NG 911 and hoping desperately that federal funding for NG 911 would like come to the rescue, right? It would magically give us all this surplus in funding to do GIS work. But it keeps getting cut at the federal level. And so I think we need to really find a better solution that's feasible and sustainable now. So follow the money, find the solution, right? Broadband has a ton of money. Public safety needs the same data sets as broadband. So there should definitely be discussions happening between broadband and public safety really often. And part of those discussions I propose is that we start to have that awkward conversation about how we might shift our thinking about what data sources are acceptable and how do we evaluate risk. I'd like to present quickly two opposing points of view for your consideration to help get the conversation started. So one camp is that I'll use an example here. In my area, so I was the 911 addressing person for the borough, and I had 3 cities within my borough. We had a triple homicide where ankle bracelet of the bad guy said he was at a location. Callers from another location said he was intending to harm relatives. Law enforcement showed up where his ankle monitor said he was at. They thought they searched the whole place and then they left. Turns out there was a basement apartment that had an entrance from this awkward like backyard spot. First responders didn't know about that because at the time I was not allowed to be tracking subaddress information because it didn't come from authoritative sources. But my argument to that is, I mean, the utility companies knew there was an apartment, right? USPS knew there was an apartment. They were delivering packages to apartment B. The pizza guy knew it. So how can we feel comfortable, with all of those people knowing that there was an apartment, but we're not providing that same data to our first responders? It's just
if I can jump in on that too, because in a lot of ways, I am a no data is better than bad data with kind of a further conversation to that of not if you can distinguish what is kind of unknown with your data. So, if I know a data set is bad, obviously, I don't want to include it, but if I've got a data set that's incomplete or needs adjusting, I can flag that somehow and I can use that data and I know I'm going to be working on improving it, then that's a totally fine strategy. And like Hillary was saying, it's if you've got data that has value but is incomplete, you have some sub addresses but not all of them, then you flag that town or that county or that state as we have some data but we haven't fully built it out yet, and you have access to that information. That is very different than having a data set that that was not managed properly or well. So but I agree with all of that.
Yeah, it's a major challenge and it's going to require some difficult conversations, right? And it's going to involve first responders, dispatchers, probably lawyers, the GIS folks, and we're going to have to start having a conversation about risk and data validity, data updates, the limitations of different data sets. And so that's kind of the other camp here is that providing some data that is maybe, potentially bad data is better than giving our first responders no additional location intelligence. And that's kind of the camp that I'm in. Data users need to know the limitations of every data set and its source. Yeah, this can be kind of hard to explain to trainees, right? It can be kind of hard to display on their map view. And it can be kind of hard to train on. So it's giving more data, but also it requires a little bit of extra work. But I think it's an important option to offer. So what's stopping us? Nobody really wants to talk about data liability and risk mitigation, right? If you send an invite out to a bunch of people with that as the meeting header, I don't know if people are going to attend your meeting. You may have to say donuts as the subject line. I don't know. So it's an awkward conversation, and it's going to require a lot of work, a lot of coordination. And then there's the how will we maintain all this new data? I had previously only been tasked with managing primary addresses. And then if I did get my way and I was able to start tracking subaddresses, that would have quadrupled my workload. And that's a concern, right? But the answer to that question is you have data update like subscription packages with these AI vendors, and you leverage the power of FME for conflating and integrating and analyzing stuff. So the second question is actually a lot easier to answer than that first one, but I think now is a great time for us to start having these conversations. And then just one final slide, and I'll shut up. Where do I see AI fitting in? Oh my gosh, I would have loved to have this at my fingertips when I was at local government. Extracting all the building footprints from imagery borough-wide. Well, there's my to-do list. Find me every building footprint that doesn't already have an address. Let me take a look at it. Find me every parcel that has a building footprint on it, but no assessed value for structure. Well, that's the assessing department's to-do list. Where are all the roads and driveways extracted from imagery that I don't already have in my GIS? There's another to-do list. And then have that conversation with your supervisor. Here are my to-do lists. Here's how many I think I can reasonably tackle in a month or a year. And then figure out if you need staff augmentation, contracting support, yada, yada. So, okay, sorry for going a little long, but that's what I had to talk about today. We kind of talked about broadband and public safety.
Thanks for that, Hillary. I think those are really great examples of not only how you really benefited the state, but how you were able to take some AI generated data, match that up with some local data to make the data better to serve two different purposes. So thanks for that. Tim, I know that you're leveraging geospatial data within your organization, of course. Can you share a little bit more about how that geospatial data is being leveraged in your work and how it helps with your 911 efforts in your state?
Sure, absolutely. And thanks everyone. So just a quick background, because I don't have any direct ties with Ecopia. I met Sean at a conference and kind of talking ideas, and I think I was rather critical of your first idea that we talked about. But we've kept talking, and I appreciate people who are trying to think and push the boundaries and come up with ideas that solve real problems instead of just trying to say this is going to make your life better and this is the one thing you need. So why I came on and what I want to talk about is I'm real passionate about GIS. I mean, I've been doing it here full time for over 20 years. I've been doing it even longer than that. It was part-time in college. So building out this data set and kind of seeing from where we had it to where we have gotten it today has been great. And I know from talking with other public safety entities across the country, we're in a very fortunate space. So anything I can do to help other agencies get there, whether it's with a product or whether it's with tools or workflow, whatever, I'm happy to do it. So first, just a couple of examples of kind of where we are today, right? So, we've got your center lines and your address points. We have building footprints. We've done a somewhat unique thing with building footprints where we classify them based on use type. So you can see here, green is a residence, gray is business, and then beige would be kind of a either mixed use or special case. In this case, we're looking at a college campus. So also here you can see the different polygons. Those are different emergency service zones. So first responders are going to different parts of the map depending on whether you're on campus or off campus. And that gets kind of granular in some places where you've got, the campus is going to be 911, but if we call from the train track, it's not going to go to the campus. So that's kind of an example of the level of detail that we have gone to. And just to kind of position that, here's way up north in Pittsburgh, New Hampshire, where there's more snowmobile trails and OHRV trails than houses and roads. So we've gone to the effort of going and collecting those, using local clubs to collect those, addressing those where it makes sense, trying to come up with standard names, because sometimes you have a snowmobile trail that turns into an OHRV trail, which also might be a logging road or a road to somebody's cabin. And so they can be real unique challenges. And then here's another example of just a downtown area. We've got a lot of footprints going on where we spent a lot of time drawing these from aerials, and then putting the individual addresses kind of on the entrance. We've added things like AEDs recently. But one of the things that about here is we, in various conversations talked about, while this is not an authoritative data set from or mandated by the state to have this, what we have done on this level is build this over time, and we eventually have whoever is the addressing authority for this district sign off that this is accurate. Are there errors? Sure, there's still errors, but we're running it through all the checks and balances that we can do, and then we're running it through someone at the local level who can say yes, that's correct, or no, that's not correct. So we're getting as close as we can. I think that could apply to someone who's looking to kind of build a lot of this from scratch, where you could take something where you could get footprints auto-generated, and then you could flag them as, hey, these are pretty good. We're going to use them, but we know we've got more work to do. We want to get eyes on them. We want to put, address points or entrance points on there. We want to add building footprint names. Whatever you want to do, however you want to build there, you could do it in a way. I think that's kind of, you stage it in as long as you have a way in the background to stage it. The other thing I wanted to just touch on real quickly for anyone who is, in the public safety arena and trying to figure out how am I going to pay for this, because funding's an issue. It's a more of an issue now, I think, than it kind of has been in the past with kind of the uncertainty with inflation, which we haven't really had to deal with in a while. Something I've done that's been particularly helpful, and I'm going to just jump out real quick here if I can. All right. So I have two different strategic plans that we've written here. This one obviously was written a few years ago, which was a general IT plan for the state. And I don't want to go through all of these slides here. Obviously mission, vision statement. But what I wanted to show was, baked into the plan here was that GIS is a foundation of our values. And so it was one of the three main categories of IT for the state. And the tasks here are kind of less important. We had some minor upgrades. We've got, kind of some big server updates. A lot of these tasks, and all these tasks are essentially done. But I want to just go back to goals and values. This is something that it's a short slide. I spent a lot of time kind of trying to condense what was important for us for IT, and GIS is right in the middle of all of it. Obviously answering 911 calls is the most important thing, but I put that in there. That led to, a few years later, a GIS strategic plan, which kind of built on that, where we came up with a more formal, and sorry to be switching through this, but now we've got bigger items. We've got more items that are just GIS centric that weren't appropriate for the other plan. But what it does is kind of lays out for everyone. It's something you can get a few people at your organization to buy into, and you can put it out there and say, these are the things we want to do. And hopefully you can get people to agree on it. And when it comes time for funding, or to not cut funding, at least, you can say, well, look at all the things I had planned. If you cut funding, we're not going to be able to do this, or we're going to miss these deadlines. I have referred back to these plans several times in conversations like that. And it's been a good tool for me. So just wanted to share that real quickly and see if there's any questions on that. So I'll stop sharing that at this point. So sorry, Dan, I think I killed your PDF.
Oh. Well, I think we can put that back up again. I think we just have a couple of more slides there. But another great example of how you're taking data and mashing it. I don't want to say mashing it together, but finding data that's better and putting it together to come out with an outcome that meets your needs. Let's go to the audience now. I know we have some time for questions here, and I'd really like to hear some thoughts from the audience on what questions they might have as it relates to plugging in AI information, or either Hillary or Tim, how you integrated data to make this better for the organizations that you're supporting. What do we have? Questions from the audience? I'm not seeing any in the Q&A right now. I would encourage folks to add them. I have one. Tim, as I was listening to your presentation, it was kind of a manual approach. How long did it take you to, because that was a great set of data, how long did it take you to get to that point?
Yeah, I mean, years and years, honestly, and it's not like every bit of data is done for every town, because where a lot of our stuff has been manual, it's been we get to a town and it's time to review the data on the town. We get it up to current specs, so to speak. It's what I talked about earlier, where we spend a lot of time making sure we've kind of versioned our towns and kind of know where they are. So it's been a lot of work, which is why some of the things that we talk about today, being able to automatically generate a lot of this would give other agencies a big jump start on getting that data set.
So Sean, I'm curious, how long did it take to generate the data for Alaska?
So Alaska's really big. I think it's like what, 1.7 million square kilometers, something like that. So a lot of it was just, honestly, it took probably a month or two, just because we hit that scale and we can shove the imagery through the engine is in by the bulk load and identify, find all the nooks and crannies. There were some interesting things we kind of like discovered, like in the tundra, some of the rocks can look like building footprints, but our QC process did a good job kind of like filtering that out. Like every new geography, we have to like tweak it a little bit, or we learn more a little bit. But yeah, it was really quick. We were under a tight deadline. We had I'd say like a month to get it done so we could get it in time for the challenges, which again, Hillary brought up, like it was confusing when you had to have your challenges in by, and there wasn't a lot of like people you could ask to get clarity on, how do we, in Alaska, they have some folks that live in storage sheds or the storage containers, and like it's seasonal and fishing and like, what do we do there? How do we say that's a BSL, right? When people are actually like living in there and they could use the internet and they probably should have it for that portion of the time. So there was definitely some interesting things we kind of had to hash out, but in general, it's pretty quick.
And I'd say the building footprint features that you guys did extract were so much better than any of the other data sets we have, right? There are some other big nationwide building footprint data sets, but they're old. They are missing a bunch of the changes. And honestly, when you look at them in Alaska, their algorithms went completely wonky. Like they're capturing ice chunks floating down a river as a building, and sea ice also as a building. So ice seemed to be something that tripped them up. And the tundra is kind of a polygonal shaped ground structure that they were like, buildings everywhere, and it's just the permafrost rich tundra. So when I finally did get that Ecopia data set in hand, I was like, oh, thank you. Somebody's figured out how to do this for Alaska. It was really great.
So the notion is AI can benefit, but at the same time, you have to have that human intervention and that QA/QC to make sure that what you gain in efficiency, you don't lose in data quality by combining that data and really looking it over. We do have a couple questions in the Q&A tab. I'm going to start with Zach. The question is, how exactly is the service for, say, extracting building footprints delivered? Software tool, ArcPro extension, delivered data set? Sean, that's likely one for you. You're muted, Sean.
That would help. Thank you, Dan. Yeah, it totally depends on your preference. A lot of times it's, if it's a smaller area and we're doing really intense land cover mapping, we'll just say, hey, here's a shape file that you can kind of like attribute it on the different features, and you can symbolize it and bring it in and kind of just use it on your servers. We have worked a lot at how do you deliver like cajillions of vertices, right? Cajillions of polygons in an easy way. So we do have a platform, and we put a lot of sweat into figuring out how do you deliver 3D data, how do you deliver like vector data really smooth so that you can kind of just like bring it into your existing applications. So however we need to, we're pretty flexible. I mean, that's the advantage of being kind of a young company too, is we can always dig in and figure out how we need to solve any engineering issues.
So just to summarize what I think I heard is fully compliant with the Esri tools, QGIS, those sorts of things, and you work with the customers to deliver it in a form that they need.
Yeah, that's more eloquently put. And also our platform, we have some customers using it as feedback loops, as like a feedback tool. So we love if one of our customers says, "Hey, we know we're asking you to extract hard stuff, and it's not going to be perfect. It'd be great if we could give you the feedback." So we kind of set up this platform as well where they can tag it, they can push it to us, they can let us know where things are off. So we can either like improve the algorithm for year over year stuff, or just kind of like dig in and fix features.
Great, thanks. We've got another one from Matthew DeLong. Thanks, Matthew. He's reaching out to you, Sean, to say, Sean, can you speak to the preferred imagery source for a footprint update? Presumably you have a production process tuned for a particular imagery source, but could you, for example, take a newer image source and use for an update?
That's a great question. Matt obviously knows about imagery shift in mosaics and things like that. So our feature extraction works on any imagery, right? Like we'll use even near map, kind of like oblique imagery and get, roof geometry and, what percent of the roof is stained, stuff like that. We can do stuff like that. We cut our teeth on satellite imagery. So like that 30 centimeter resolution satellite imagery, we can do like a lot of land cover features. And then over time, we formed a really good relationship with Hexagon, where we have access to a lot of their 30 and 15 centimeter imagery that they've collected as part of the NAPE program. We've also done a ton of jobs on just whatever your custom whatever you flew, right? Like whether it's Sanborn or Wolford or whatever you have. So doing updates, it's preferable to have like the raw stereo data. Because if we're building the data set in 3D and we're like feeding in a new, like more raw image database year over year, then we can kind of like conflate it a lot better and easily track changes. Going one mosaic to another is harder because imagery can shift, like, even if you're like 2 meter, 3 meter accurate, which is great for satellite imagery, that could be 6 meters off, right? So roads and fine tuning features like sidewalks, like lining up perfectly is tough. So it usually kind of just depends on the setup. Obviously, if we can get access to the 3D data, whether it's like the multi-view stereo data, we can crush that really easy. Doing mosaic to mosaic, we just kind of got to do a little bit more work.
Okay, thanks for that. Sean, early on you mentioned, and I don't know if everyone caught it, but I heard you mention updates and change. Can any of you talk about how you manage change in the environments you work with? And what I mean by that is we're always taking pictures of the Earth, right? So we can update. But I imagine that with this new method, that managing change and updates, especially on the urban fringe and some of those other areas, is really a bonus because you can do it very quickly with the processes that you have, Sean.
Yeah, I don't know if, Tim, you want to take on like how you kind of manage change, right? I mean, I can tackle it from the AI perspective, but
yeah, I mean, it's like anything that's not there's not one single thing that manages the change. we have some people who go through, and we on a regular basis we review every single town, from all the roads, all the data in it, labeling, all of that. We also have websites where officials that we designate from each. In New Hampshire, it's the local municipality that's the addressing authority. It's not the county. So one of our challenges is dealing with 234 different addressing authorities. But we have a website where we encourage but can't force, because we're an unfunded mandate state, towns to participate and let us know when something changes. We try to make that requirement pretty simple. We don't want too much information, just kind of enough to find the new structure or to identify what's been changed, and then we'll reach out for more information. But we're trying to make it real simple. Log on, tell us something different, we'll investigate further, and we'll fix it. So we solicit feedback from people who are local. We review with new aerial data like everybody else will. We also try to really track every single change once a community has been accepted. So once we have what we consider an authoritative data set for a town, any change from that point on, obviously we're going to use Esri tools to track any changes we make to the features. But every time we get a submission from a town, or anytime we find a new structure, we're going to make a control point right there, and we're going to note what was added, when was it added, who said it was okay. So whether that's coming from a website or coming from an email, that's tracked, that's logged, that's tied to the feature, so that we kind of have a chain from when this data has been accepted to, okay, well, now it's been 5 years, we've added data to it. So it's a convoluted process, but it's, when you're talking about 911 and trying to keep things, to a very high level of accuracy, that's the level that we go to.
Thanks for that. John or Hillary, anything to add to that?
Sure. I know that my triggers when I was that local government addressing person were when a new plat records, our cadastral team would draw it in using the meets and bounds description. It would come to my desk, and I would have to assign addresses to all of the newly created parcels except for corner lots. And for corner lots, we'd reach out to property owner to say, which road are you accessing from? Because we want to assign you the appropriate address. Another trigger would be if there was a road realignment project and a road name was changing. That would also trigger a look at the addresses that were already assigned to the old road, and notifying property owners that the road name was changing, and so is your address. Change management is definitely not an easy or simple thing to do, but I sure know that it would have been helpful to have, like, every year, as scheduled, I would get a data dump of everything that's new that can be seen in our 6-inch, ortho-rectified imagery that we buy every year. That just would have been an amazing and helpful tool, instead of waiting for a 911 discrepancy report saying, hey, we responded to a structure that you don't have. So
I hear you.
And I'll add a little. I mean, this is awesome, and this is why I'm so glad Tim joined, right? Because he built this from the ground up and has been managing it. And I come from this. I biased, of course, but I come from this other angle of, look, there's pictures happening all the time. There's imagery collection happening all the time. We're getting really good at putting cameras on vehicles and collecting imagery and feeding it all. And so this world has gone from, since I joined, Digital Globe in 2007, it's let's map everything. And now it's, how quickly can we remap everything, right? And so I love where it's going, where the technology is going, where from our perspective, we just want to be able to feed our government customers, our friends, where we think we see change as quickly as possible and as accurately as possible. And we feel, we're biased, of course, that we're getting really good at it, where, hey, 95% of the stuff that we tell you is probably going to be accurate. And so a lot of this webinar was hey, what's government's appetite to bring that into the workflow really easy and figure out ways to make it authoritative, right? As quickly as possible. And so, it's changing every day. Every conversation I have, with Tim or a lot of the folks on the call, it's, it's kind of like we're blazing trails.
Yeah. We do have one more question in the chat or in the Q&A session. Ted asks, does your address point data integrate with your road center lines? And we'll take this question and then we're going to wrap up. So
I knew Ted was going to ask this. This is why I hang out with people like Hillary. You know, Ecopia is really good at extracting whole lots of data. Like all the roads we extract are actually like unnamed. We have at times gone through like with our addressing database and said, let's make a deliberate effort to attribute things right. But a lot of these, you know, that's why we team up with folks like AppGeo or Dewberry to say, hey, like, can you throw on some white glove GIS service and make broadband challenges or tie in, you know, road center lines to address points, or do we need to make driveways so we can connect them or things like that, right? So I don't know if that answers, Ted. Maybe Hillary can be easy for you, right?
Yeah. Oh, yeah. I'd say, you know, through the FME scripting and data conflation and the use of readily available authoritative data, it's pretty easy and possible to associate addresses with road center lines. And for buildings that don't have an address, it would be easy enough for us to do some machine learning, you know, coach the model into guessing, well, if the address on the left is this and the address on the right is this, or the road range is this, and we're smack dab in the middle, here's an approximate address. And that's how those, you know, address assistant, you know, Arc Pro extensions and Arc Map extensions work. They sort of do that guessing and offer you a suggestion, and you can tweak it from there on either side. So,
And to add one more real quick thing, like this is something Hillary and I talk about is, okay, we made these address building footprints across the U.S. How hard would it be to turn it into like a next gen 911 data set, right? And like change the attribution fields and parse everything together. And, you know, we'll probably have to spend some time with Tim to coach us up on it.
well, it's time to wrap up. I want to be mindful of everybody's time today. First and foremost, I want to thank our participants today. Thank you all for joining and submitting your questions. And a special thanks to Sean and Hillary and Scott. It was a great discussion. Excuse me, Tim. It was a great discussion, and I really appreciate you coming to share your story. And every time I sit in on one of these, I learn something. So thanks to you all. Have a great day, everyone.
Thanks, everyone.